Balancing chemical reactions. Chemical equations are short ways of showing what goes on in a chemical reaction. A balanced chemical reaction is a representation of the law of conservation of mass. Specifically, there must be the same number of atoms of each element on both sides of the equation. Here, black represents carbon atoms, red oxygen atoms, and white hydrogen atoms. The equation itself is a shorter and simpler way of showing the chemical reaction that does not show the structures of the substances in the reaction. It uses the formulas to represent the substances. As such, the formulas may not be changed while balancing the reaction. In fact, the only things that can be changed are the coefficients of the substances. Note that the number of atoms of each element is the same on both sides of the arrow. The reactants appear on the left of the reaction. The products appear on the right. The arrow always points to the right. The states of the reactants and products may be included in parentheses after the formula, but are not required. To balance the equation, we adjust the coefficients until the numbers of atoms of each element are the same on both sides of the reaction. Subscripts and coefficients give different information. The subscripts within the formula tell us the number of atoms of each element in the molecule, while the coefficients tell us the number of molecules in the balanced reaction. Reaction types. Reactions are organized into different categories. Most organizational schemes place reactions into 5 or 6 categories. It is important to remember that these categories will overlap to a certain extent, and that they are not complete. That is, not all reactions will fall into one of the categories. We will look at 3 reaction types in this video. One of the types of reactions is called either synthesis, which means to make, or combination. It involves the combination of 2 or more substances to make a single substance, which must be a compound. The combining substances may be all elements, a mixture of elements and compounds, or all compounds. The key to identifying a combination or synthesis reaction is that only one product is formed. Here are some reactions in which 2 elements combine to make a compound. Magnesium burns with a bright white light in air. The reaction is even faster and more intense in pure oxygen. When steel wool is heated and placed into pure oxygen, flames can be seen. White, sometimes called yellow, phosphorus will spontaneously burst into flames when placed in pure oxygen, leaving a white powder of diphosphorus pentoxide behind. When sulfur is heated to its melting point, it turns dark. This liquid burns with a blue flame in pure oxygen. The opposite of a combination reaction is a decomposition, which involves a single compound breaking apart into a number of substances. The products may be all compounds, a combination of elements and compounds, or all elements. The key to identifying a decomposition reaction is that there is only one reactant. A third type of reaction is called combustion. The most common type of combustion is the combustion of carbon compounds, often hydrocarbons. In this case, the reactants are the hydrocarbon and oxygen gas, and the products are carbon dioxide gas and water vapor. Sometimes, combustion is defined to include any reaction with oxygen that produces oxides, binary compounds with oxygen. In this definition, reactions can be both synthesis and combustion if they involve an element reacting with oxygen to make the oxide. One example is the burning of magnesium.